All right, so you should have your blue circles out, and I just want to quickly review what we talked about on Friday. First of all, I said to you guys that we always start, the unit circle always starts on the furthest spot to the right. What is the furthest place to the right?
1.
Oh, it's right here. We call that 0. Do you recall, you guys?
Yeah.
We call that 0 degrees. And we always rotate in what direction around a circle?
Counterclockwise.
You always rotate counterclockwise. So we're going to be rotating up and to the left as we work around this circle. So up here we call this 90 degrees. We rotated another 90 degrees. We ended up over here at 180. We rotate another 90 degrees. You end up down here at 270. And then you end up right back where you started, which is also known as 360. So 360 and 0 are exactly the same place.
Oh.
All right. Now, we talked about, remember I drew that thing over there on the board? The backboard by Marcellus. And I told you guys that that is what's happening. We have a circle right where the X and the Y coordinate grid, where they meet. And this circle that you see right here is a blown up version of that circle right over there. Okay, so it's just big to make it easy for you guys to write on and so on. So this right here, remember this is called the x-axis, and this right here is the y-axis. This point right here in the center, this is the point 0, comma, is the point 0, comma 0, also known as the origin. Very good. So this point way over here on the right, we said because it is exactly 1 unit to the right and not up or down at all, we called it the point 1, comma 0. Right? This point up here at the tippy top, it is up 1 unit, it's not left or right at all, so we called it the point 0, comma 1. This point over here on the far left, it is 1 unit to the left, it is not up or down at all, so we called it the point -1, comma 0, and then of course this point down here is down 1 unit, not left or right at all, so we called it the point 0, comma -1. Are we okay with that? So if I gave you a blank circle right now, you would be able to fill in those few points. All right, so let's keep going, because I'm not going to give you a blank copy of this and have you fill it in until I give you more information first of all. So, first of all, I want you to recognize that this right here, if I rotate around the outside of the circle and I stop right up here at 90 degrees, these lines, segments inside the circle, kind of separate, they kind of divide the first quadrant into a bunch of different parts. This first rotation right over here is 30 degrees. So right here next to that degree symbol, you're going to need to fill in 30 degrees. Skip the next one. Don't cross it off. Just skip it for a second. And rotate another 30 degrees, which brings you to what? 60 degrees. And then if I keep rotating, we'll be back at 90 degrees. What goes halfway? What goes right in between 30 and 60? 45 degrees. So we have 45 degrees right here. Now, there is an infinite number of degrees all the way around the circle. I could ask you guys to figure out what are the coordinates, what are the x's and the y's at 25 degrees and 0.1 degrees and 10.794 degrees. I could give you an infinite number of places to calculate the x and the y. These are kind of the main ones, the ones that you're going to have to, not really memorize, but you're going to have to know how to calculate very, very quickly. These are like the main ones. All right, let's keep going all the way around the circle. If I rotate another 30 degrees after 90 degrees, that puts me at 120. I'm going to rotate 15 more degrees. That's going to put me at 135 degrees. I rotate another, puts me at 150. And then I rotate another 30 degrees, we're at 180. Keep going, 180 plus another 30 puts me at 210. 210 plus 15 puts me at 225. Rotate another 15 degrees, it puts me at 240. I rotate another 30 degrees, it puts you at 270. Rotate another 30, we're at 300. Then we are at 315 degrees, and then if I rotate one more time, I'm at 330 plus another 30 degrees brings me right back to the 360 degrees. Now, if I have not said this to you already, you can use this blue sheet on your test. So please, don't be messy. I will try to keep this as the least congested as I possibly can. So don't make mistakes, don't write things down wrong, don't get lazy, because someday you might be really, really happy that you have this in front of you, okay? All right, now what we're going to need to do, at 0 degrees, we had to figure out what was the x value and the y value. We had to do that at 90 degrees, we had to do it at 180, we had to do it at 270. So what we need to do now is figure out what is the x value and the y value if you have rotated up here to 30 degrees. So I'm going to switch over to this. So what I'm asking you to do is figure out what is that point right there. That would be if you were on a circle and you would rotate it up to here 30 degrees. What is the x-coordinate and the y-coordinate at that point? And all that means is this. How far over are you and how far up are you? How far over and how far up is that point? So what I need you to do, I'm going to take you back to trigonometry for just a minute here. I'm going to draw a triangle, and you don't need to write this down. Just listen to me for a few minutes. I'll tell you when you can start writing again. If you have a 90-degree angle here, and this angle right here is 30 degrees, and you know that the hypotenuse is 1. And I asked you to figure out what is the length of the bottom of this triangle. I'm going to call it x. What kind of a relationship do you have? A sine, a cosine, or a tangent? You have a cosine. Very good. You have a 30-degree angle here. This is adjacent to it. This is the hypotenuse. So if I asked you to figure out what x is, you would say, okay, well, the cosine of 30 degrees is equal to x over 1. X is being divided by 1. How do you solve for x? You multiply. So to figure out the x, you would say x equals 1 times the cosine of 30 degrees. So please, right now, on your calculators, I would like all of you to, first of all, make sure that you are in degree mode. Make sure you're in degree mode, and then I want you to calculate this for me, please. One times the cosine of 30 degrees. 1 times the cosine of 30. You get 0.866. Yeah? And that's a rounded value. But now what I would like you to do is, on a blank screen, on your calculator, I want you to type this in. Type in square root of 3. Type square root of 3. Finish your parenthesis. Finish your parenthesis, please. And then press divide 2. By 2, what do you get? You get the same answer, right on? Square root of 3 over 2. So that means that the bottom of this triangle has a value of the square root of 3 over 2, also known as 0.866. Am I okay with you writing 0.866? No. And the reason I'm not is because this is a rounded value. If you write down the square root of 3 over 2, that is a real value. This is rounded, this is real. I want the real value. I want the actual value. Are you okay with that? Now, usually someone says to me right now, how did you know that these two things were the same?
I know these two are the same.
Great question, Turner. How did I know? How did you know that those two things are the same? Well, this is why. This triangle is a very famous triangle. It has a 30-degree angle.
The right triangle.
It has a 90-degree. It's more than just a right triangle. We have a 30-degree angle. We have a 90-degree angle. What is the measure of that last angle? 60. Okay? So we call this triangle a 30, 60, 90. And there is a relationship that exists between all the sides in a 30, 60, 90-degree triangle. If you have the hypotenuse, which we do, it is 1 unit. The short side is always exactly half the length of this side right here. What is half of 1? 0.5. 1 half. It's 1 half. So this side right here is 1 half. And then if you have the short side, to get the long side, all you have to do is take the short side and multiply it by the square root of 3. How do I know this? Because I learned it when I was your age, because some math god somewhere, sometime a long, long time ago, figured out that this relationship exists for every 30, 60, 90-degree triangle. What is 1 half times the square root of 3? I don't want a decimal. It means the square root of 3 over 2. We already know the decimal value. What's the decimal value of this? 0.866, approximately, rounded. All right. So that is how I knew that 0.866 is the same thing as the square root of 3 over 2, because I knew the relationship between the sides of the 36 to 90 degree triangle. All right. So what is the length of the bottom of this triangle? Hello? Square root of 3 over 2. It's this. Yes? Okay. Go back to this. Don't write anything yet. Just listen for a second. That triangle that I just drew for you is right here. Do you see it?
Oh my god.
For what?
Oh, can you believe it? Okay, this right here. How many degrees is this arc?
30.
It is 30 degrees. If this arc is 30 degrees, what is the measure of this angle right here?
30.
It is 30 degrees. Right? What kind of an angle is this thing called, Turner?
Isosceles?
No, it's this angle.
Central. The angle, it's a central angle.
It's a central angle. Very good. It's a central angle. So this arc is 30 degrees. It means this angle is also 30 degrees. Do you see the triangle here? Here's your right angle. See it? Say yes, Mrs. Corrigan. We see it.
Yes,
Wow. That
Oh
is
my gosh.
fascinating. This arc, yeah, this arc right here.
Yeah, it
It's
curves.
supposed to be. It's an arc.
Yeah, but it can't be 90 degrees with a curve.
No, no, no. I'm not. That's not what I'm talking about. This side right here with the x-axis. I'm not talking about the arc.
What you do, Lou.
Is my side crooked or something? No. God, I thought I did a good job of drawing that. Here is my 30, 60, 90 triangle. What is the length of the radius of my circle? What's the radius of the circle, you guys? 1. It's 1. I've heard it, but not from very many people. This is a 1 unit circle. The radius of this circle is 1 unit. Remember this point right here is the point 1, 0. That's because it's 1 unit away from the center of the circle. So this segment right here, the radius right here is 1. What is this of this triangle? The 1 is the what? It is the hypotenuse of the triangle. So if I switch back to this right here, that is the radius of the circle. My hypotenuse of 1 is also my radius of the circle. So what I would like you guys to do is right here in this point right here, you got to tell me the x value. What is the x value at that point? How far over is that point?
Square root of 3 divided by 2.
Very good. Don't write it down wrong. This you can use this on the test. So this x value is the square root of 3 over 2. Fill it in. The x value at 30 degrees is the square root of 3 over 2. Now what I'm going to do is go back to this. Go to a new page. I'm going to draw the same triangle.
Maybe 0.5.
Here's 1. This again is a 30-degree angle, but now I want to figure out this side of the triangle. Here's your 90-degree angle. What kind of a relationship do I have here? A sine, a cosine, or a tangent? Jackie, pick your head up, please. Sine, cosine, or tangent. What is it? This was cosine. We were trying to find this. It was cosine. What is that? What is y in relationship to the 30-degree angle? Emmanuel. It's the opposite. And then this right here is the hypotenuse, which means we have a sine relationship instead of a cosine relationship. So we would do this. The sine of 30 degrees is equal to y over 1. How do I solve for y? 1 times sine of 30. Do it, please. Type it into your calculator, get an answer. What is 1 times the sine of 30?
Is it the same thing as a
0.5. It's 0.5. same thing as 1/2. Didn't we already know that, you guys?
Yeah.
Because we talked about it a little bit ago when I was talking to you about all the relationships between the sides of the 30, 60, 90. All right, so what is the y value at this point? It is 1/2. So this point on a unit circle has coordinates of the square root of 3 over 2, comma, 1/2. Watch what I do. If don't write this down. Just listen to me for a minute. If I take this point and I translate it across the circle, and I end up right here, what I have done is created another triangle over here. It has a 90-degree angle there. It has a 30-degree angle right here. Isn't this new triangle exactly the same as the first triangle?
No.
It's just like flipped over the y-axis.
Yeah.
So if I start here at the middle, how far to the left is this point?
Negative square root of 3 divided by 2.
It is negative square root of 3 over 2, comma. How far up is it?
1/2.
It's up a half of a unit. It's up 1 over 2. Now, is it a positive 1 over 2 or a negative 1 over 2? Well, it's up. I went to the left, which is the negative direction, then I went up, which is a positive direction. Okay?
Are we supposed to draw that thing too?
Nope. All I want you to do, because I don't want your circles to be messy, because if they're messy, then they get overwhelming to look at. All I want you to do is write in the coordinates around the circle, okay? So this circle and the x and the y axis has a ton of symmetry. You don't have to necessarily memorize everything. It has a lot of symmetry to it. All right, what about down here? Same triangle, would you agree? Here's your 90-degree angle. How far to the left is, whoops, I didn't go all the way over. Here's your 90-degree angle. How far to the left is this point right here?
Negative square root of 3 divided by 2.
It is negative square root of 3 over 2. How far down is it?
Negative 1 divided by 2.
Negative 1 over 2. Don't forget your negatives. Two negatives. They are both negative here. We have the same triangle over here. Okay, so how far to the right is this point right here?
Square root of 3 divided by 2.
It's the square root of 3 over 2. How far down is it?
Negative 1 divided by 2.
Okay, Emmanuel has it, you guys. Square root of 3 over 2, comma, negative 1 over 2. Okay, now, I'm almost done, you guys, I promise you. Let's say you have a 45-degree angle. If this is a 45-degree angle, and this is a 90-degree angle, what is this missing angle up here?
45.
It is also 45 degrees. What kind of a triangle do I have if I have matching angles? It's an isosceles triangle, which means that side and that side are exactly the same. So if I asked you to figure out the bottom of this triangle, call it an x, and you know that the hypotenuse is 1, what is that side and what is that side of this triangle? What is the x? Adjacent, what is this? The hypotenuse. Adjacent and hypotenuse is what? Cosine. So the cosine of 45 degrees is equal to x over 1. Figure out what x is. What do? No, the x is on the top.
Oh yeah,
So you just multiply. So you're going to take 1 times the cosine of 45. What do you get? 0.707. Now, it just so happens that because of a similar situation with the 30, 60, 90-degree triangle, this has a radical fractional value too, and its value is the square root of 2 over 2. How do you figure that out? That's a story for another day, and I will tell you, but I'm not gonna do it now because it gets pretty in depth. Not horribly, but more than we need to get into. So for now, you just need to accept it's square root of 2 over 2. But I will tell you right after I'm done here. Okay. So what I want you to do, guys, flip your circles over. And write this down, please. On the back of your circles, I want you to write down 0.866. Write it down. 0.866. What did that mean? What does 0.866 mean? Thank you. Square root of 3 over 2. What does 0.707 mean? Square root of 2 over 2. 0.707. This right here. Right here. 0.707 means the square root of 2 over 2. And did I tell you that you can use these on your test?
Yes.
They might be helpful to know that 0.866 really means the square root of 3 over 2, and 0.707 means square root of 2 over 2. Okay. Back to your circles. So I want to just remind, so you have heard nothing that I've said so far?
Please excuse interruption. I have a couple of quick announcements. Mentors, if you have a middle school mentee, there will be a sign-up table starting tomorrow through Thursday by Mr. Lapidus' room. Please bring in $3 that will help towards your pizza party for this Friday's luncheon with your mentees. And juniors and seniors, aftershave t-shirts will now be $8. The t-shirts will only have a front design with no names or numbers on the back. You can order them during lunch in the comments on Tuesday and Wednesday. You must pay when you order. Again, aftershave t-shirts have now been reduced to $8.
Okay. I do know we're running out of time. I want to finish up. I'm almost done. I just want to recap what happened. To figure out that x value, let me just remind you what you did. To figure out the x value, you took you found the cosine of the angle. To figure out the y value, you had to take the sine of that angle. Are you with me, you guys? So to find the x value, you take the cosine. To find the y value, you take the sine. So we're at 45 degrees. How do I find the x value at 45 degrees? Turner, what do you do? To find the x value, what do you do?
The thing over 3 over 2.
Well,
Cosine.
1.
you take the cosine of 45 degrees. Do it. You guys do it. What do you get? You should know. We just did it. What is the cosine of 45? You get square root of 2 over 2. So this is the square root of 2 over 2. To figure out the y value, you have to take the sine. So you do the sine of 45 degrees. What do you get? You get the square root of 2 over 2. Let's do 60 degrees. Find the x value. How do you find the x value? Shane, how do you find the x value? Do the cosine. All right, so you need to do the cosine of 60. Do it. What is the cos of 60? You have 0.5, right? What are you going to write? You're going to write half. Don't write 0.5. Write a half. Find the y value. That means you take the sine of 60. What is the sine of 60? Do it. Sine of 60, you get what? 0.866. So it's the square root of 3 over 2.
I didn't know it was the square root of 3.
That's the whole explanation.
Always.
Cosine of 120. Do it. Cosine of 120. What do you get?
This is going to be that negative half.
You get negative 0.5, right? Negative 1/2. What about the y value? Find the y value. What do you do? Sine of 120. What is it? Square root of 3 over 2. Your job is to finish this circle. And all of you, if you walked away with nothing today, the one thing, except for one thing, the one thing you should walk away with is how do you calculate the x and the y at an angle and on the circle. So what is it? How do you find the x?
Cosine.
How